Assalamualaikum warahmatullahi wabarakatuh. Hi, in this video I'm going to talk about the tangent problem, and you will see that at the end of this video the solution to this problem is obtained by applying the idea of limits. Now suppose that you would like to find an equation of the tangent line to the parabola y equals to x squared at the point P, where the coordinate is given by 1 and 1. So in order to find the equation of the tangent line, we already have point P here, which touches this curve and also the line. So this is tangent line T. So in order to find the equation, we need to know what is the slope. Okay, so we need to know what is the slope, and the slope is given by m here, so we need to find what is m. So once you have managed to find the slope and you already have the point here available, then you can construct the equation using this familiar looking formula. So y minus y1 is equal to m x minus x1. Okay, now our first challenge is to find m, and for that purpose you actually need to know another point on line T. So on this red line here, you need to know another point. Unfortunately, you don't have it. The point doesn't exist. You don't know what is the point on the line. So what we can do is we can approximate the slope here. You can try and guess what is the slope here by choosing point Q on the curve. So this is the curve. You can choose point Q because you'll be able to know what is point Q, since we have this function given, which is y is equal to x squared. So you will be able to choose a point along this curve. Now, based on that point, you can compute the slope of the secant line, and we are going to call it MPQ. So MPQ here is the slope of the secant line, and basically you can construct the line from point P to point Q, and based on that you can compute the slope of that line. Okay, so it will look like this. So you can see that there is a line connecting the red point and the blue point over here, and so this is what we call the secant line, and you can find the slope of this line. Okay, now of course when you look at it, it doesn't look close at all to the slope that you are looking for. Okay, it looks totally different. The slope here is totally different than what you are trying to find, which is the red line here, the slope for the red line here. But you will see that later on, if you consider point Q to get very close to point P, so if you move the point here as close as possible to point P, then the slope of that point MPQ will approach the slope that you are looking for, which is M. So to illustrate this statement given here, I've considered introducing, for example, this green point here. So basically this, you can imagine this point here is going downwards, so it gets closer to the red point. And if you consider this secant line for this P and Q, so we can call this the new point Q, it will look like this. I hope you can see it. I'm going to enlarge this image so you can see that if you connect the red point, the green point here, so you have the slope which is not exactly similar to the red slope, but we are getting there. So let's say if you introduce another point, okay, you let that point get closer to point P, for example this point over here, and if you consider the slope for this point MPQ, So it will be looking like this. And you can see that by connecting the red point with this brown point here, the slope of that is now similar to what you're looking for. Okay, so you can see this, I hope. And that's the meaning of this whole sentence here. When the point Q gets very close to point P, the slope of MPQ will approach the slope that you are looking for. So there you go. Now, I think it is better to illustrate the whole situation here with a concrete example. And here is the example where we are considering moving. So we are considering moving point Q as close as possible to point P. So again, this is point P, this is point Q. So this is the tangent that we're looking for. Sorry, this is the tangent line, and we need to find what is M. Okay, so basically for this example, for this table here, you can see that X is going downwards. It is moving from 2 to 1.5 and gets to 1.001. So basically it's moving in this direction. So X, the value of X is moving closer and closer to 0.1. Okay, and when X is moving closer and closer to 0.1, so you can see that when X is 2, the value of Y is somewhere here. When X is, let's say, over here, you can see that the value of Y is going this at this point. When X is closer to 1, the value of Y is going to be here. So basically we are moving the point closer and closer to point P. Now if you consider this table here, you can see that X is moving upwards from 0 to 0.999. So what's going on here? So basically the point X is moving in this direction. It is approaching 0.1. It is approaching X equals to 1. And so if you can see that if X is somewhere here, therefore the value of Y is somewhere on this curve. If the value of X is here, you can see that Y is somewhere here. So the point here is moving closer and closer to P. Now the reason why we are doing that have already been explained in the previous slide, which is when the point gets closer and closer to point P, we will be able to estimate the value of M. Alright, so now let us try and do this. Okay, so for the first one here, when X is equal to 2, okay, so for the first one here, when X is equal to 2, you will see that the value of Y is going to be equal to 4. And how do you find slope? Again, slope is just slope is y2 minus y1 over x2 minus x1. Now you can set this point here P11 as, so we can say that P11, so this can be your value of x1, this can be your value for y1. So therefore for this one is the value of x2 and this one is the value for y2. So using these values, you can plug into this formula and you will be able to get that the slope for this one is going to be equal to 3. Okay. Now when x is 1.5, y is going to be equal to 2.25. So this is the value of x2 and this is the value of y2. Again, plug these values into this formula here. Then the slope that you will be getting is equal to excuse me, 2.5. So keep on doing this for other values of x. And for the last value of x, when x is 1.001, the value of y is going to be 1.002001. And again, this is the value of x2 and this is the value of y2. So the slope when x gets closer and closer to 1, you see the value of x is 1.001, which is very close to the value of 1 here for p coordinate. Then the slope of this one is going to be equal to 2.001. So that is the pattern that you will see when x comes from 2 and going to approach 1 in this direction from the right direction. Now let's look at the next table where x approaches 1, this point here, which corresponds to this point P. So let's look at this table when x approaches 1 from the left direction. So when x is 0, y is equal to 0. So this is the value of x2 and y2. Again, plug in these values into this formula here. And you'll be able to see that the slope is going to be equal to 1. Next, when x is 0.5, y is going to be equal to 0.25. So this is the value of x2 and y2. Plug in these values into this formula and you will see that the slope is going to be equal to 1.5. Now keep on doing this for other values of x. And for the last value here, you will see that y is going to be equal to 0.998001. And by substituting all these values into the formula, so this is the value for x2 and y2, you will be able to get that the slope for this one is 1.999. Okay, so based on this, I'm sure that you will be able to see that when x gets closer and closer to 1, the value is about 2.001, and when x gets closer and closer to 1 from the left direction, which is 0.99 here, the value is 1.999. So we can sort of guess that the slope of the tangent line is going to be very close to 2 or something like that. Yep. So what can be concluded from the above experiment is that first, limit of the slopes of the second line is the slope of the tangent line T. Okay, so what we have done just now, what we did just now is that we keep on computing the slopes of the secant line. So these are all slopes of the secant line. And there is the limit here because the value of x here gets closer and closer and closer to value of 1. So that's the idea of limit. So that's where the limit comes from. So limit of the slopes of the second line is the slope of the tangent line T, because we have shown in the previous slide that when the point Q gets closer and closer to P, we can see that the slope of the secant line approaches the slope of the tangent line. Yeah, and so this whole statement here can be written in a more simple form by using mathematical language, which is given by this one. So this is basically saying that limit of the slopes of the secant line, so this one, as Q approaches P, is, so this is the symbol for is, slope of the tangent line T, we have already given a name to that, which is equal to M. And based on the results from both tables here, we can safely guess that the slope of the tangent line must be equal to 2. Okay. Now, we are not done yet because our objective is to find the equation of the tangent line, and I'm sure that you can obtain this answer here when you consider this formula, which is y minus y1 is equal to mx minus x1. So your x1 and y1 is given by this fixed p coordinate here, and m is equal to 2. So you just substitute all the values here, you will be able to get the equation of the tangent line given as such. Okay, I think that's all for now. Thank you very much for watching.